Today, I'm going to talk about something that about how we developed the RISC-V 50 TOPS compute for mass production. And it was very tough journey when we make decisions. So I introduce myself. I'm Yuling. I run DeepComputing. So for those who are not in RISC-V circle or industry and probably don't know us, so who we are, we are focused on making RISC-V premium products, and we are the pioneer. We're focusing on normal consumer electronics and like tablet and speakers. We did try. And then the second thing is the modern personal computing device. Like now we launching the AI PC. And then last but not least, something fun about RISC-V. So some remote control cars for my coming grandkids. Okay, so I'm 50. So and some balloons. So and that this is the balloon and flew over in the year before the Law of American Summit, just before the U.S. government shut down the Chinese balloon. So I decided to make a balloon. It represents freedoms. The problem of RISC-V SOC is that in every segment, every industry already flood with SOC, either powered by x86, powered by MIPS, powered by PowerPC, Spark, ARM, and RISC-V don't know where to go. None of our SOC manufacturers, they don't know where to go. And then the second thing is that we do not know what is the computation power we want. So the SOC didn't know 12 nanometer, how many gigahertz, and then how much DDR support, and how many TOPS we need to put it in. The third thing is that the whole RISC-V ecosystem resource is really limited. So I give you an example. This company alone, the human resource is more than the whole RISC-V ecosystem, the whole industry, including all the companies. So you know how scarce the resource is. So, and we're running against life. So RISC-V been here for 15 years. So we just ratified RVA 23. We're very excited. So we are running against most of the SOC manufacturers running against life, because so far none of them can be compete, can be mass produced and mass volumes. So you can see RISC-V journey is very hard. I think AI journey is going to be even harder. So you take a look, the model used to be in the AI 1.0 or the AlexNet, ResNet, blah, 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 blah. And then suddenly it becomes transformer. And then now suddenly in DeepSeek, it even blow away NVIDIA. So so it's bound to be RISC-V. So AI framework, and you think about CUDA, compatible to PyTorch and Llama, CPP, or Llama, blah, 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 a lot of frameworks. So when you design an AI accelerator, you need to work with a range of AI framework. Is really hard and mega hard. So for example, give you an example. When one of my friends AI chip, they decide the chip is against TensorFlow 1.4. By the time the chip come out 2 years later, then it's TensorFlow 1.5, and suddenly PyTorch 3.0. So, and they spend all the effort porting again. By the time finished porting, another 2 years ago. So their chip is probably, and the PCI car is 5 years old. It's non-compete. Okay. And all day we do in RISC-V in AI is porting, optimizing, but not mass produced, because no one use it, because not never ready. So how can we make RISC-V AI a little bit more successful? So my approach is to break the chicken and egg. I don't care how crap the hardware is, make it into the product and open it up and give it to the market, give it to the open source community, and to let the world, 20 million open source developer to play around it, and they help you to optimize it, right? Don't do everything ourselves. We can, I can, basically I can. We start up. RISC-V just nice start up. Unknown. Just be fair unknown. Right? And we do as much as we do it retrofit no goes, right? Just plug and play as much as possible. Take a look at our framework laptop. The modular, we can swap the motherboard, becomes x86, ARM, whatever. It's everything modular. Okay, it can be upgraded as well. This way, no good, throw it away, another one comes in, right? So that's how we do it. Yes, hardware now. I'm very excited, in the coming version of AI motherboard, we use the modern technology called chiplet. It's the best invention in the world. So it solves a lot of chicken and egg problems. So it's just chiplet, just 9 Lego blocks. So, and it's in semiconductors. And the rest is the PCIe host and device or Type-C or those standard interface. It's very exciting. So with all these standard, then you can play a product with Lego retrofit approach. And you'll be faster and you'll be less resource needed. So take a look, right? Take a look the chip we use. You think about this is one chiplet, this is 2 chiplet, and they go for peer-to-peer bus. So it's very fast. So, and before, if you decide a core, you put all together, you need probably another 100 people, man, right? So you bid, okay, let's decide a 4 core first, assuming we're going to do a core, right? And then you chiplet it out, and now in a 4 core, we can't sell 4 core stuff, right? We had to have some A core because ARM is not doing any 4 core anymore. So in the mid high end stuff, so then we have 4 core, right? A core. Then you chip it out, you can see fantastic spec. Okay, we do some invention as well. They're very powerful DSP. So let's do some emulation of RVV 1.0 on DSP. And the community will be happy to help you on this. You don't have to do it as a hardware manufacturer. So that's the great thing about Lego approach about chiplet, SoC. Take a look, this is PCIe, right? This is all chiplet. Chip. The whole damn thing is 200 TOPS, right? There's a 400 gig DDR. So that's eating up the AMD inference. You can see all by PCIe bus, I'm standard host. So this is very fantastic, very quick. I can do a board in 4 months mass produce, right? So you close the time to market and let the market tell you whether it makes money. It's not, I do this for, it's not taking much. It's you have $250,000 only. So you can see. Chiplet AI world, PCIe host device simultaneously. The best invention of chiplet and PCIe. So you can even do internet over PCIe, right? That's and then you guys see we partner with Framework, the modular laptop, very famous laptop, and anyone wants a new laptop, go and buy a Framework. All right, don't buy in HP, Lenovo, Dell. Those are tied with Intel. And you think about it, this is a Framework. Everything is replaceable, fixable, and upgradable. And they have a lot of product line, 12-inch, the desktop, 13-inch, 16-inch. You think about it. Now I'm making the 13-inch motherboard for the laptops. We're trying to push as much as we can. Just $300. So we're gonna do. You think about it. This AMD chip at the moment. We're gonna put everything together. Just now you see, put in the one board. There's there's probably 250, 300 TOPS with half terabyte of DDR there. You're gonna run DeepSeek is very fast. It's very affordable. When you go by chiplet and PCIe and conventional LPDDR, it's very affordable. Yep, so I said this 16-inch, and I do another module for it. This called for 16-inch module. So we are paralleling somewhere here. They have a booth. They design this module. So we only need to do the PCB here with 100 TOPS here. So you can plug into their 16-inch laptop. So that this is a Lego way. It's a very standard way and Lego way, upgradable way. So it's cheap things. So affordable. So this is our roadmap. So and yeah, it's same as announced, and very exciting RISC-V. And hope you guys see it in the real market and this year. Thank you.